Friends and dear viewers, I welcome to the present episode wherein we are going to continue our discussion with regard to landforms of highland glaciation. Friends, I remember in my earlier episode I concluded with the words like the plucking and abrasion, etc. I don't take much of the time in going back. I just continue with the aspect that is abrasion. Friends, as earlier defined, abrasion is nothing. It's a process. It's a process of erosion of the glaciers. One of the process of erosion of glaciers. Here, the glacier scratches, scrapes, it polishes, and scours the valley floor with the debris that is frozen into it. Of course, these fragments are the powerful tools of denudation. Right? I think you remember the meaning of denudation in my earlier episode. I defined. Okay, and large angular fragments, they cut deep into the underlying rocks. So all glaciated floors generally bear the evidence of striation or scratching. It is striation or scratching. And the finer materials smooth and polish the rock surfaces and produce a finely ground rock floor. Okay, finely ground rock floor. Right. Now let us move on to the characteristic features of glaciated highland. And of course, friends, generally I felt that briefing up with one-line narration, etc. But now I think I should give deep insights to each and every term I mean generally we come across in our discussion, right? So it could be a little bit exhaustive. If hopefully I think I finish this entire topic in this current episode only, if time permits. If not, let us continue the following session, right? The first one is the Kori or Sark. Kori or Sark, both are one and the same. And of course, it can also be called as CWM. CWM, it's a geographical technical term, dear friends. You need not bother. You can just remember like Kori or Sark, what it literally means and what the activities it perform, right? The downslope movement of a glacier from its snow-covered valley head and the intense shattering of the upland slopes tend to produce a depression where the fern or neve accumulates. Fern or neve is nothing but the types of snow, dear friends, right? And the process of plucking operates on the back wall steepening. It and the movement of the ice abrades the floor so that deepening the depression into a steep horseshoe shaped basin. By this process of plucking and of course steepening as well as steepening of the floor and deepening the depression into a horseshoe shaped basin, and that is called as a cirque. And of course, it has its origin from French, dear friends. Cirque is a French term which explains that a horseshoe shaped basin is formed because of the steepening and deepening process that operates due to plucking. And that is a cirque. It is also known as Kori. In Scotland, and CWM in Wales. Dear friends, this particular horseshoe shaped basin which is formed due to plucking process, and of course in that course steepening and deepening also occurred, leading to formation of a basin. And that particular basin, which looks like a horseshoe shape, is betterly called as cirque in French language, and Corrie in Scottish language, and CWM in Wales. Where in Wales, right? There is a rocky ridge at the exit of the Corrie, and when the ice eventually melts, water collects behind this barrier to form a Corrie Lake or tarn, TR and tarn, right? So don't get confused with these technical terms, dear friends. It is very essential for us to know each and every possible term, right? Let's move on to the second feature, that is arids and pyramidal peaks. Arids and pyramidal peaks. Friends, when two corries cut back on opposite sides of a mountain, knife-edged ridges are formed. And they are called as arids. It's a French word, dear friends. A well-known British example of an arid is the striding edge on Helvellyn in Westmoreland. I come again once again. A well-known British example for this arid is the striding edge on Helvellyn. Found in Westmoreland. And where now arid is nothing but cutting back of two corries on opposite sides of a mountain. Suppose if there is an instance where three or more cirques or corries, when they cut back together, let's see what happens. And their ultimate recession will form an angular horn or pyramidal peak. This angular horn or pyramidal peak is a resultant of more than three cirques or corries when cutting back a mountain on opposite directions, so resulting into the formation of what do you call this angular horn or pyramidal peak, my dear friends. And the Matterhorn of Switzerland is a classic example for this angular horn or pyramidal peak, dear friends. Okay, the Matterhorn of Switzerland is a classic example, right? Now let us move on to the other form, that is the Bergschrund. At the head of a glacier, where it begins to leave the snowfield of a corrie, a deep vertical crack opens up. That is called Bergschrund. This is a German technical term, dear friends. And in French it is called as Rimaye. I come again once, dear friends. At the head of a glacier, where it begins to leave the snowfield of a corrie, a deep vertical crack opens up, and that is called as Bergschrund in German language or Rimaye in French language. Basically, this happens in summer, when although the ice continues to move out of the corrie, there is no new snow to replace because of summer. And of course, in some cases, not one but several such cracks may occur. The Bergschrund presents a major obstacle to climbers. Further down, where the glacier negotiates a bend or a precipitous slope, more crevasses or cracks are formed. Further down, down this glacier, you find more number of bends or precipitous slopes, and these are called as crevasses or cracks, right? And now the other one is the U-shaped glacial trough. The U-shaped glacial trough. The glacier on its downward journey, fed by ice from several quarries like tributaries, and just like a river, they join. And it begins to wear away the sides and floor of the valley down which it moves. And in this process, it scratches and grinds the bedrock, removing any rock, debris, and surface soil. Okay. And it tends to straighten any protruding spurs on its course. It's implied. Okay. And the interlocking spurs are thus blunted to form truncated spurs. Of course, spurs are nothing but the protrude forms in that course. Basically on the floor of the floor of valley formed by the glacier. And the sharp-edged things they are called as generally spurs. And while this debris, when it is moving down, and those spurs are being turned out into truncated spurs, basically due to smoothing process. Okay, smoothing process of these floors and valleys of this dip and valleys. A valley which has been glaciated takes a characteristic U shape with a wide, flat floor and very steep sides. And after the disappearance of the ice in the deep sections of these long and narrow glacial troughs may be filled with water, forming ribbon lakes, such as the Loch Ness, the Loch Ness and Lake Ullswater, Lake Ullswater in Britain. They are sometimes referred to as trough lakes or finger lakes also, friends. The ribbon lakes, they are sometimes also called as trough lakes or finger lakes. The best examples are Loch Ness and Lake Ullswater in Britain. The next landform is the hanging valleys, dear friends. The main valley is eroded much more rapidly than the tributary valleys as it contains a much large glacier. It's of course implied. After the ice has melted, a tributary valley therefore it hangs above the main valley so that its stream plunges down as a waterfall. When it gets seized and the tributary gets seized, it just appears to be a hanging one that hangs upon the main valley. It gives such kind of reflection, and that is called as and of course these valleys, if they are more in number, the tributary valleys, if they are more in number, they can be called as the hanging valleys, and may form a natural head or water for generating hydroelectric power. Basically, that is the reason, friends. Many of the European countries, of course, in the cold or temperate climates, you find more number of the hydroelectric power plants. That is the advantage. And of course, even if you observe in countries like India, there operates a number of hydro power plants on the foothills of Himalayas. You find more number in those areas. Basically, that is all due to these hanging valleys and all, right? Now let us move on to the rock basins and the rock steps. A glacier erodes and excavates the bedrock in an irregular manner. As in a natural course, we can imagine that irregularities may occur, and the fashion is also be irregular one. Need not if in ideal conditions, then we can expect. In a particular manner. So a glacier generally operates in natural conditions and in different climatic conditions. So generally it erodes and excavates and the bedrock in an irregular manner. The unequal excavation gives rise to many rock basins. Later, they may be filled by lakes and in the valley trough. Of course, we have earlier discussed, right? And now in this process, we can see the rock steps also, dear friends. You can see the rock steps. A series of rock steps may also be formed due to different degrees of resistance to glacial erosion of the bedrocks. That is the reason why these rock steps they form. Let's move on to the moraines. The moraines. Moraines are made up of the pieces of rock that are shattered by frost action, embedded in the glaciers and brought down the valley. And those that fall on the sides of the glacier, mainly the screes from the lateral moraines, which I explained in my earlier episode, friends. So when two glaciers converge, their inside lateral moraines unite to form a medial moraine. It's a medial moraine. The rock fragments which are dragged along beneath the frozen ice are dropped when the glacier melts and spreads across the floor of the valley. And even this also we have discussed yesterday. This is called as a ground moraine. This is called ground moraine. And the glacier eventually melts on reaching the foot of the valley, and the pile of transported materials left behind at the snout is the terminal moraine. Is the terminal moraine or end moraine? So, friends, these are the important things. That is the ground moraine, the terminal moraine, and the lateral moraine and middle moraine. These are the few technical terms that you should keep in that you should bear in mind. Okay. Right. The deposition process when it comes to end, and we see the end moraines. Okay, and these end moraines may be in several succeeding waves at the as the ice melts back by stages. So that a series of recessional moraines are also formed. And imagine if the glacier flows right down to the sea, it drops its loads of moraine in the sea. And if sections break off as icebergs, morainic material will only be dropped when they melt. Where the lower end of the trough is drowned by the sea, it forms a deep, steep-sided inlet called a fjord. Make a note, dear friend, it's the most important word. That is a fjord. Fjord. It's a fjord. A fjord is nothing but if a glacier flows right down to the sea, it drops its load of moraine in the sea. If sections break off as icebergs, morainic material will only be dropped when they melt. Where the lower end of the trough is drowned by the sea, it forms a deep, steep-sided inlet, and that deep, steep-sided inlet is called as fjord. Is called as fjord, a typical of the Norwegian and South Chilean coasts. Okay. It's generally found in Norwegian waters and South Chilean coasts, this fjord, right? And now we come across with the landforms of glaciated lowlands. So far we have seen the uplands. Now we are going to deal with the glaciated lowlands, right? Landforms of glaciated lowlands are mainly depositional in nature and brought about by both valley glaciers and continental ice sheets. The valley glaciers, they leaves behind the eroded materials in only restricted areas. And the imprint of ice sheets on the landscape is far more widespread because they are advanced through large areas during the ice ages and scouring and removing any surface soil and rock debris on their ways. And of course, as a result, it has been estimated that almost a third of the total land surface of Europe and North America is littered with glacial and fluvio-glacial materials of all kinds of descriptions like moraines, the boulder clays, the tilts, the drifts, rock floor, the gravels and sands. Okay. Many of them may be being re-eroded or restored or redeposited, etc. elsewhere, even and the present rivers also, dear friends. And most of the glaciated lowlands have depositional features, as if I stated earlier. But where rock masses project above the level surface, they result in striking features of erosion, and such as the Roche Montana and crag and tail. The Roche Montana and crag and tail. Right now we'll deal with the Roche Montana. This is a resistant residual rock hummock, a residual of rock hummock, and the surface is striated by ice movement. And its upstream side is smoothed by abrasion, and its downstream side is roughened by plucking. I think these two words we have discussed in the start of our episode, dear friends. Keep in mind. The term Roche Montana or Roche Montane is used to describe such a feature because it resembles a sheep skin wig once worn in France. Generally, if, French people, if we observe the movies or any visuals of that French people, earlier, in the history, in earlier days, we can see they used to wear the wigs for their head. They used to wear wigs for their head, and particularly that is sheepskin wigs. The sheepskin wigs they used to wear on their heads. These French people, and that is technically called as Roche Montana. That is Roche Montana. And now let's move on to the crag and tail. Let's move on to the crag and tail. Friends, the crag is a mass of hard rock with a precipitous slope on the upstream side, which protects the softer leeward slope from being completely worn down by oncoming ice. It therefore has a gentle tail. The classic example is the Castle Rock of Edinburgh in Scotland. The Castle Rock of Edinburgh in Scotland. Edinburgh Castle is located on the crag and the high street on the tail. Right. The following are the typical depositional features, dear friends. The boulder clay or the glacial till. Next one is the erratics. Friends, I need to give a brief discussion about the erratics. These are the boulders of varying sizes that were transported by ice, and they come with the advancing glaciers or ice sheets. But when the ice melted, they were left stranded in the regions of deposition, and they are called as erratics. Of course, because they are composed of materials entirely different from those of the region in which they are found. Basically, we can imagine, friends, when during the course of flow of water or etc., they used to collect various materials that may be dissolved or form in a solid state, and in that process they get collected at a particular point, and so you find generally a different collection altogether, which is not native to that particular region of deposition, right? Sometimes the erratics may be found perched in a precarious position just as the ice dropped them, and they are then termed the perched blocks, right? Friends, for these perched blocks, we have good classical examples. They are found in lowland as well as in highland areas in Europe. Example, the Silurian grids, they are found perched on the Carboniferous limestone of the Pennines. The Pennines are the ranges. They are generally found in Europe. Their presence in large numbers in a hindrance of farming. Now let's move on to the other one, friends. That is the drumlins. The drumlins. These are the swamps of oval, elongated, whale-back hummocks composed wholly of boulder clay. Okay, composed of boulder clay. They are arranged diagonally and so are commonly described as having a basket of eggs topography. Having basket of eggs topography, and a large number of them are found in the county down in Northern Ireland and the glaciated plain around the Great Lakes in North America. In North America. That's about the drumlins, and now let's move on to the eskers. These are long, narrow, sinuous ridges composed of sand and gravel, which mark the former sites of subglacial meltwater streams. Right? They vary from a few feet to 200 feet in height and maybe several miles long. In some parts of Maine is a place in the United States of America. Maine is a place in United States of America, and the outstanding eskers form a continuous ridge of 100 miles. Forms 100 miles. Of course, they are very numerous in the Scandinavia. Scandinavia, that is example um, the Pankarzu esker of Finland, the Punkarzu or Pankarzu, you can spell in a way. The Pankarju esker in Finland. Of course, eskers are made up of highly porous sand and gravel. Water is rapidly drained off from their crests and they may not support many trees. Though in Finland they often form tree-covered ridges between lakes. Of course, we know the terminal moraines, friends. I need not discuss. And important one more thing is there, friends, the outwash plains. The outwash plains. These are made up of fluvio-glacial deposits washed out from the terminal moraines by the streams and the channels of the stagnant ice mass. Stagnant ice mass. And cames. Cames are the small rounded hillocks of sand and gravel may cover part of the plain. Okay. Later we need to talk about kettle holes, dear friends. Right. The depositions of this, where the deposition takes the form of alternating ridges and depressions. If deposition takes the form of alternating ridges and depressions, and the latter may contain, the ridges may contain the kettle lakes and give rise to characteristics, knob and kettle topography. The most interesting and surprising thing, dear friends, when you find deposition that takes place in the manner alternating ridges and depressions, and particularly the ridges with deposition, they contain the kettle lakes, and these kettle lakes they give rise to characteristics of characteristic of knob and kettle topography. Characteristic of knob and kettle topography. Things I think we have the other thing also, the human aspects of glaciated landforms, dear friends. And with regard to human aspects of glaciated landforms, we need to discuss about a few things like the glacial drifts, the benches or the Alps, the good pastures, and of course the animal migration type of farming, that is the transhumans, and the Lewis plains of the Europe and the central United States of America. United States of America, and the gravelly outwash of plains, the ice covered surfaces, as so on and so forth, dear friends. I think I have given a very exhaustive description regarding these various landforms that are formed with glaciers. Of course, the depositional as well as the erosional features also. Friends, I think I should conclude now and let us start our discussion with a fresh topic that is the landforms, Aeolian landforms. Right? Okay. Hope you all enjoyed this session, dear friends. Let's meet in our following episode. Thank you. Thank you, one and all.